All right, let's get right into it. We're going to talk about the secret science behind one of the coolest pieces of tech you probably own, noise-canceling headphones.
You know the feeling, right? You put them on, you flip that switch, and suddenly the roar of a jet engine or the rumble of the subway just fades away. It seriously feels like magic, like you have your own personal cone of silence. So how on earth do they do it?
Well, and this is the really wild part. The answer is that to create quiet, these headphones actually have to make more sound. I know, it sounds completely backward. How is that even possible?
Okay, so first things first, we've got to understand the enemy. What exactly is this noise that we're trying to get rid of? So any sound, whether it's your favorite song or a loud construction site, is really just a vibration traveling through the air. You can think of it like the ripples you see when you drop a stone in a pond, only, well, they're invisible. These waves have peaks, areas where the air is bunched up, and troughs where it's spread out.
Now, every single one of those sound waves has three main characteristics. You've got frequency, which is the pitch. Think high notes versus low notes. Then there's amplitude, which is just how loud it is. But the real secret sauce, the key to this whole thing, is phase. Phase is all about timing. It's exactly where the wave is in its up and down cycle. And that timing, it's absolutely everything.
Okay, so we know what a sound wave is. How do you destroy it? This is where the physics gets really, really cool.
See, the universe has this pretty simple rule. When two sound waves run into each other, their pressures just add up. So if two peaks meet, you get a bigger, louder peak. If two troughs meet, you get a deeper trough. But what do you think happens when a peak meets a trough? Well, that's where the magic is.
It's a trick called destructive interference. Get this, if you can create a brand new sound wave that is the perfect mirror image, like the exact evil twin of the noise you don't want, they completely cancel each other out. The new wave has its peaks where the original has its troughs, and when they meet, poof, they just vanish. So the whole process at its core is this simple equation. The headphones listen to the outside noise, they instantly create an opposite anti-noise signal, and they play it into your ears. When those two waves meet right at your eardrum, you get silence. It's brilliant.
But here's the thing. Creating that anti-noise is actually only half the battle. The really good headphones use two totally different methods at the same time. It's a two-pronged attack.
So, on one side, you've got what's called passive isolation. This is basically just a fancy physical barrier, like a good set of earmuffs. And on the other side, you've got active noise cancellation, which is the smart electronic system we've been talking about. And as you'll see, each one is a specialist at tackling different kinds of sounds.
The passive part is all about brute force. The big, plush ear cups create a physical seal around your ear. The foam inside actually absorbs sound energy and turns it into a tiny, tiny amount of heat. And the sheer weight and density of the materials help block sound waves, especially those higher-pitched sounds, like people talking nearby.
And here is the high-tech toolkit for the active part. There are tiny microphones on the outside listening to the world. Then there's a powerful little computer, the digital signal processor, or DSP, which is the brain of the whole operation. It analyzes the sound and calculates that perfect anti-noise wave. Then, the regular speakers inside your headphones play it back. And all of this happens in less than a millisecond. It's insane.
Okay, so we've got the toolkit. But it turns out there are actually a few different ways engineers can put it all together. And each design has its own unique pros and cons.
This is so cool. The feed-forward design puts the microphone on the outside, so it gets a little head start on the noise before it reaches your ear. Then you have feedback, which puts the mic inside the ear cup to hear what you're hearing and make constant corrections. It's like a little quality control check. And then you have the hybrid approach, which does both. It uses mics on the outside and the inside. This is why the really premium headphones are so mind-blowingly good at what they do.
So if this technology is so smart, why isn't the silence just perfect? I mean, why can you still hear a car horn or someone clapping?
Well, the first reason is that active noise cancellation is a specialist. It is amazing at getting rid of low, constant droning sounds, things in the 20 to 1,000 hertz range. Think about airplane engines, the hum of an air conditioner, the rumble of traffic. That is its absolute sweet spot.
But being a low-frequency specialist is only part of the story. The real challenge, the reason you don't get total silence, comes down to a few fundamental hurdles in physics and engineering.
Here are the big ones. First, there's a tiny processing delay. We're talking microseconds, called latency. For a low rumble, it's no big deal.
But for a high-pitched sound, the waves are so short and fast that even the tiniest delay means you miss the target. Then you have unpredictable sounds, like a dog bark. They're just over before the system can even react. And finally, the cancellation is perfectly tuned for one tiny spot in space, right at your eardrum. If you move your head even a little, the effect can waver. And this brings us to a really important point about how our brains perceive sound, something called psychoacoustics. The engineers who design these things know that it's those low droning noises that actually make us feel tired and stressed out. So getting rid of that specific noise is way more important and more pleasant for us than creating some kind of weird, unnatural total silence.
So, the next time you put on your headphones and the world fades away, just remember what's happening. The goal was never really to achieve perfect, absolute silence. It's about giving you perfect control. The power to curate your own audio world, turning down the noise and turning up what really matters to you. It's not magic, it's just really, really clever physics.